is bell-shaped enough. So outlier ID number 2. So what do you think? If the data is not bell-shaped enough, what are we not going to use?
Standard deviation.
We're not going to use standard deviation, or its partner in crime, the average. Because that's the whole point. If it's not bell-shaped, you shouldn't be using those things. Because they're getting skewed. They're getting pulled too far on a standard deviation and too far to one side on the average. So if we don't use the average and standard deviation, what should we use? What's left? Relative position. Thank you. No, I heard median. Is that what I heard? Yeah, median is a measure of relative position. Yeah, we're going to use relative position. So here's, do you remember in class last week, and you haven't got these quizzes back because Amber still got them, but the snowfall data you guys played with, and at the very end of class, I tried to predict which of your groups had outlier data, and I was up here with my fingers going like this, and I said, you guys do, you guys don't, you guys do, you guys don't. What I was doing was this. I was doing a geometric version of what we're about to talk about. So the first thing I did was I went like this, where? Do you remember?
The inside, the middle box.
Nice! And that's got a name in statistics. It's called the interquartile range.
Okay.
So the first thing you got to do, step 1, find your interquartile range. Quartile range, which is called your IQR. And all that is, me going like this, geometrically, is the same thing as taking Q3 and Q1 and subtracting. That tells you how far they are apart. I don't know what they are because I didn't look at them when I ran those numbers before. Let's do it again. Looks like it's 15. 75% of you said I was less than 180 pounds. And 25% of you said I was less than 165 pounds. That means 50% of you said I was between 165 and 180 pounds. Everybody buy that analysis? Half of you in class said I was at least 165 pounds, but no more than 180. 25% of you said I was less. 25% of you said I was more. But the middle 50% said I was between 165 and 180. And I am. Yay, so a middle 50% you got me. Cool? Fair so far? Good. Okay, good. Median, 170, very similar to your average, which lends credence to the idea that it's pretty bell-shaped. That lends credence. It's not proof. It's just leaning. If your median was vastly different than your average, then I'd think, somebody guessed really, really low. So Lauren, even with your 145, technically speaking, it's not so low it's pulling the average significantly. Probably because of Maya's 150s there as well. Working with the standard deviation, you've got not just 1, but 2 kind of unusually low, but not that unusual based on metric. Okay, anyway, for my weight loss data, this is going to give us 180 minus 165, it's 15 pounds. Now, what do you think that correlates to with outlier ID number 1? What does that correlate to?
Your standard deviation.
Essentially, that's like a standard deviation. Essentially, it's like, and I'm doing this in quotes, big quote marks. Sorry, George Carlin, miss you. It's operating on the same idea of it's giving us a range of values, 15 pounds. Now, what did we do once we had a standard deviation with bell-shaped data? To set up our range, what do we do to it? Took X bar, plus or minus?
2.
2 of them, yes?
Yeah.
Now here's where it deviates a little bit. It's not 2 in this case most of the time, it's 1.5. Why? I have no good answer for you. I've seen this number change over the past 20 years a number of times. It used to be 3, then it was 3 sigmas. Serenity mentioned that earlier. I've seen these numbers change as the status quo changes. Right now, to identify what are called mild outliers, step 2, what you do is you take your IQR and you increase it by 50%. Why? YouTube world, I have no good answer for you, other than that's what we're doing right now. I mean, how this stuff, kind of like why we still use the English system in this country to measure things, and we haven't gone over metric. Probably because it's too ingrained at this point, and it's too hard to change. For whatever reason, we're going to take 1.5 times that IQR. I wish I had a better reason than this, but I don't. I wish I did, but I don't. Okay, so you increase it by 50%, which would then become, what, 22.5 pounds? Make sure I did my math right on that one. If you're thinking about the corollary to what I did last week, that's when I took the box and then stretched it to make it 50% bigger. So it went from 15 to 22.5. Fair enough? So now we're there. Now I'm standing at the board with my fingers 50% longer than the IQR. Remember what I did with that once I had it?
Compared it to the long whisker on the top.
Good, very, very good. I did it very quickly, so it was hard to see exactly what I was doing, but that's exactly what I did, Lauren. I compared it to just the long whisker and the short whisker. So I took that box and I stacked it on the quartiles. I stacked it starting on the upper quartile and above, and on the lower quartile and below, and those are my fence posts. This looks terrible algebraically, I apologize. But here's, can I use the word fence, is that okay? Fence post, fence, as far as the region, the endpoints of the range. So the high fence, you're going to start, turn this off for a second, we don't need it right now. For the high fence, you're going to start with the third quartile, Q3. And you're going to add that previous number onto it, the 1.5 IQRs. So you start with your 75th percentile, and then you add your 1.5 IQRs. We are deviating greatly from the idea of plus or minus 2 standard deviations, because if you would think about using this with relative position, we probably go with Susan's median. But the median actually has nothing to do with this computation. Why? I have no good answer for you. It just doesn't. It's not what's used. I wish I had a better answer than I don't. So they take the IQR 1.5 increase, add it to Q3. Let's figure that out. Q3 I think was 180, yes?
Yeah, plus 22.5.
Plus 22.5. So if anybody gets 202.5 or higher, that's too big. You did not. Even if we round that off to the 200, Carolyn's still under it.
That's not out.
So exactly, so Carolyn's 195 is not an outlier because it's within that fence set at 202.5. That would be too high. So if somebody gets 205 or 210 or 215, first of all, I'd start buying smaller clothes. And secondly, that would be unusual based on relative position, based on the median idea. Is that fair enough?
Yay.
But now the question is, and you guys aren't either. Beautiful, you guys are already calculating it, the low fence. Good. The low fence. Excellent. That'd be Q1 minus the same IQR multiplication. Notice how it's minus and not plus because you're going below it. And this, again, was what I was doing with my fingers with the boxes on those box plots on Thursday. So, that was 165, yes? Minus your 22.5, which ends up being, was that 142.5? There we go. There's your low fence. So rounding that off to whatever you want to round it off to, whether it's 140 or 145, depending on which one, it's directly in the middle, right? So you pick 140 or 145, but either way, 145 is right there, but not below it. It's not below that value. So it looks like, even based on this, we don't have any outliers. Sometimes they agree, sometimes they don't. Sometimes you'll get different results depending on which one of the two methods you use. That's just because of the mathematics. There's just nothing magical about it. It's because of the mathematics. This wears students down. I think you understand what's going on. Now you see the construction of what is done. If you compare it to your graph, and back to Natasha's question, it would be awesome to have those lines on the graph. Unfortunately, we do not. It's unfortunate. So here's 145 right here. So your fence would be over here, 142.5. There's 195, where the fence would be over here, and you can see pretty clearly that everything's between the fences. Now, much like the standard deviation calculation that you did one time with Bert and Ernie, I don't expect you guys to ever do that again. Not that it's hard, because it's not difficult. It's just annoying. It's annoying to do that. So what I want you to do now is turn a second plot on your TIs. Turn a second plot on your TIs. So let's start